In this session, we are going to talk about how you can easily do chi-square tests manually. If you want to check out how to do them in a software that is SPSS, I have the videos in the channel. You can go back and view those videos as well. But herein, it is quite important for all the students who are new to research, who are beginners, and who want to learn how to do the test manually. So this video is going to tell you all about chi-square tests. Chi-square test is used especially when you have categorical data. Hence, it is a non-parametric test. It is of two types. One is chi-square goodness of fit, wherein you try to assess whether the observed frequencies of the data match with the expected frequencies. And the other is test of association, wherein you try to find out the association between two independent variables. So if I want to find out whether there is a significant association between the gender and the color preference, so I'll do a chi-square test of association. In case I want to find out whether the observed frequencies match with the expected frequencies of a single sample available to me, in that case, I'll do a chi-square goodness of it. So let us start and see how it is carried over. Chi-square test is a statistical technique for analyzing categorical data. It compares the observed frequencies, what you actually got through calculation, with the expected frequencies, that is what you would expect by chance, to check if the data fits a specific distribution. This one is known as chi-square goodness of fit. And if there is a significant association between the two variables we want to find out, then we go for the chi-square test of association. So herein I have put in two examples, which I'll show you how to solve them manually. First, let us go with chi-square goodness of fit. A company claims that its employees are distributed among 4 departments in the ratio 3:2:3:2. So this is the ratio of the employees of a company, the number of employees distributed in the 4 departments, right? A random survey of 100 employees gives the following observed frequencies. So in case you get this type of a question, you usually get the observed frequencies table, wherein you can check that what was the observed frequencies out of the survey which was conducted. So survey was conducted on 100 employees. You see total is 100. And how many people were found in each department? In department A 35, B 18, C 30, and D 17. So this was the distribution of employees. Now, whether this distribution follows the theoretical distribution, the projected distribution, which is in the ratio of 3:2:3:2 for A, B, C, D department respectively, we are going to find it out through chi-square goodness of fit test. For this, the first thing is that we frame the null hypothesis. The null hypothesis in this case is there is no significant difference in employee distribution between observed and expected frequencies. And the alternate would be there is a significant difference in employee distribution between observed and expected frequencies. Okay, so how to do it? After stating the hypothesis, we calculate the expected frequencies. So how to calculate the expected frequencies in this case? We have the ratio of frequencies which is given to us. Sum up all the ratios, 3:2:3:2, that makes 10. So once I have calculated the sum of ratio which is available to me, 10, for each part of this ratio, how to find out the expected frequency? The formula is simple. Ratio part, that is 3, divided by 10 into 100. That gives me 30. Ratio part divided by 10 into 100. 2 divided by 10 into 100 is 20. Likewise, we can do it for 3 and 2 again, which is same as above, right? So we got expected frequency as 30, 20, 30, 20. Now, we apply this formula to get the calculated chi-square value. This is the formula. Summation of observed minus expected frequency So we square up this thing and we divide it by expected frequency. How to do it? For an instance, we look at A, department A. Observed is 35, you see here, which is given to us 35. We put it over here. Expected we have calculated, you see, for department A, 30, as per the ratio which was given to us. Similarly, we do it for B, C, and D as well. Then observed minus expected, 35 minus 30 is 5. Squaring it up, you get 25. And dividing it by the expected, that is 30 in this case, you get 0.83. So 25 divided by 30 is 0.83. Similarly, we do it for B, C, and D. The total comes out to be 1.48. So this is our calculated chi-square value. Now we have to compare this calculated chi-square value with the table of chi-square values. Where to compare it? So you have a standard chi-square table available to you. We have to compare this with that according to the degrees of freedom and the significance level of the test. So how to do it? Let us see. First, we compute the degrees of freedom. The formula for goodness of fit test is n minus 1. That is 4. 4 departments were there. That is n. Minus 1 is 3. Right? That is the degrees of freedom. Now check the chi-square table value at 5% significance level. That is the level of our testing. And 3 degrees of freedom, which we took it out. It comes out to be 7.815 through the chi-square table. I'll just show you the chi-square table. So you see, this is the critical values of chi-square, also known as chi-square table. You can easily download it from Google and use it. Now we have to look in 3 degrees of freedom. You see 3 degrees of freedom 3 at 0.05 level of significance, which is this. What is the value? So if we go over here, we get 7.815, right? 7.815 is the chi-square table value. So whatever calculated value we got for chi-square through the formula, we have to compare it against this chi-square table value. In case the calculated value is more than the table value, we reject the null hypothesis. So let us see what is the result in our case. The chi-square value which is calculated by us in this example was 1.48, which is lesser than the chi-square table value, which is 7.815, which we located in the table also. So in this case, we fail to reject the null hypothesis and conclude that there is no significant difference between observed and expected frequencies. And the result comes out to be that the company's claim about employee distribution in the 4 departments is statistically significant, right? The observed frequencies match well with the expected frequencies. So that is how you do chi-square goodness of fit test. Now let us go to chi-square test of association, which is also known as chi-square test of independence. So for doing chi-square test of association, similarly, we state the hypothesis first and then we calculate the expected frequencies. So these are the observed frequencies given to us. The expected frequencies formula in this case is row total multiplied by column total divided by grand total. So you see row total in case of male is 50, column total is 50 again, divided by grand total, which is 100. So you see 50 multiplied by 50 divided by 100 comes out to be 25. Similarly, for female also, it's 25 because male and females are equally distributed in this case. It can vary also, right? So you have this thing. Similarly, you took out for the dislike. This was for the like, and dislike is this, the expected frequency. Now apply the formula to get the calculated chi-square value. Herein we build a table and we put all the observed values. You see male who like online classes, male who dislike online classes, female who like online classes, female who dislike online classes. So we have captured these values from the given observed frequencies and put it in this table in this form. Then we mention the expected frequencies which we took out in this table through this formula. Then observed minus expected, 30 minus 25 is 5, 20 minus 25 is minus 5. When we square it up, we get these values. and then we divide it by the expected. So here in this case, 25 divided by 25, you get 1, right? 25 divided by 25, you get 1. So we get a total of 4 in this case. This is our calculated chi-square value. Now we have to see the degrees of freedom, and according to those degrees of freedom at a given significance level, which is 5% in this case, we will see the chi-square table value and compare this calculated value with the table value. In case this chi-square calculated value is greater than the table value, we can reject the null hypothesis. Degrees of freedom in case of test of association are computed as row minus 1, column minus 1. So since we had two categories in this, male and female, and we had two preferences, whether they like or dislike. So it's a 2 by 2 contingency table or crosstabs. So number of rows is 2, number of columns is 2, right? So 2 minus 1, 2 minus 1 gives us 1. Okay, so we multiply R minus 1 by C minus 1 and we get 1. Now check the chi-square table value at 5% significance level and 1 degree of freedom. It is 3.84 as got through the table. So this is our table. Now we want to see 1 degrees of freedom. This is the 1 degrees of freedom and 0.05 level of significance. It is 3.841. So as in this example, you see the calculated value is more than the table value. It was 4 and the table value is 3.84. So we reject the null hypothesis and conclude that there is a significant association between gender and preference for online classes. So the result comes out to be there is a statistically significant association between gender and preference for online classes. So that is how you do both the chi-square tests. One is chi-square test of goodness of fit and the other is chi-square test of association. I hope this video was quite informative and you have learned a lot. Now you can easily do the calculations manually. See you next time with some more informative content. Till then, keep watching and thanks a lot.